In 1-4, we're going to be looking at angle measures. We're going to start off by talking about rays. A ray is similar to a line, except instead of going off to infinity in both directions, it has one endpoint, and then in the other direction it goes to infinity. Unlike with lines, where it didn't matter which point we put first when we named it, in this case, ray AB and ray BA are different. The endpoint comes first in the name, and then any other point that is on that same ray. Opposite rays have the same endpoint, but they go in opposite directions. So, by definition, they're always collinear. They make one line. We're going to start for our first example with three non-collinear points, J, K, and L. So, in order to draw line JK, because it has two arrows over the end, we are going to connect J and K, and just like the nomenclature has two arrows, so does our line. It goes to infinity in both directions. Next, we're going to look at segment KL. It goes from point K exactly to L exactly. Finally, we have ray LJ, so we will start at L, and we will go in the direction of J with a line that way. You'll notice that ray LJ does not extend to the right of point L. In our next section, we're going to look at a line that contains point R in between points S and T. We're going to look at these statements and determine which are true. For part A, both ray SR and ray ST start with S, and in this case, R and T are both to the right, so in this case, those are indeed the same ray. That statement is true. Looking at statement B, these both refer to lines, and so S and R and T are both on that same line, therefore this statement is also true. For statement C, ray R and S does not start at the same point as ray T and S. Although they go in the same direction, they do not have the same endpoint, so this statement is false. In statement D, both ray RS and ray RT both start at point R, and they go in opposite directions, so by definition that does make them opposite rays, which makes this statement true. Segment ST and segment TS have the same two endpoints, and so as a segment of the overall line, they are indeed the same thing, so statement E is also true. For statement F, although the 2 points ST and TS are the same, these are referring to rays, and so since they start at different endpoints, they are not the same, so statement F is false. Our next definition that we're going to look at is for an angle. An angle is a figure that consists of two different rays that have the same endpoint. That endpoint is called a vertex, and the two sides of the angle have the same endpoint, and they're both rays. So just like when we had lines, there are many different ways in which we could label this same angle, in this case angle 1, angle A, angle CAB, or angle BAC. If we are going to use all 3 points, the vertex must be in the middle. An angle also has an interior, which is inside of those points that are listed, and an exterior, which is outside those points. In the next example, there are 3 different angles that we can name. We can name angle WXY, we can name angle YXZ, or we can include the combination of those two, which is angle WXZ. Although any of those could be named angle X because they all have X at the vertex, because in this diagram that could refer to any of the 3, that could be very confusing. The protractor postulate basically says that if we put the vertex of an angle at the 0 mark here, and then one ray is going to line up with one angle on a protractor, and the other ray will line up with another angle on the protractor, then the measure of angle, in this case AOB, will equal the absolute value of the position of our first line, our first ray, minus the position of the second ray. Once we have the measure of our angle, we can then further classify it. If the measure of angle A is less than 90 degrees, we call that an acute angle. If the measure of angle A is exactly equal to 90 degrees, that is called a right angle, and we can indicate that in the diagram with this symbol. An obtuse angle has a measure of greater than 90 degrees but less than 180 degrees, and an angle that is exactly 180 degrees is called a straight angle. We are now going to use our protractor to find the measure of angle KHJ, which is this angle here. We're going to set that equal to the absolute value of the position of ray HK, which is 125 degrees, minus the position of ray HJ, which is 180, which gives us the absolute value of negative 55, which equals 55 degrees, which is an acute angle because it is less than 90 degrees. We are also going to use our protractor to find the measure of angle LHK, which is this angle here. So we are going to take the absolute value of this position, which is 90, minus this position, which is 125. So we are left with the absolute value of negative 35 degrees, which is 35, which is, again, because it is less than 90 degrees, an acute angle. The angle addition postulate says if I have an overall angle of angle RST, and I have some point P in the interior of that angle, then the total measure of that angle must equal the measure of angle RSP plus the measure of angle PST. So in our example, that means that given that the measure of our overall angle LKN equals 145 degrees, that the measure of angle LKM plus the measure of MKN must equal 145. So we can set this up as an algebraic expression. So 145 equals 2x plus 10 plus 4x minus 3. So to simplify that, 145 equals a total of 6x, and then 7 minus 3 is plus 7. So minus 7 from both sides, 138 equals 6x, and so x equals 23. Now, what the question actually asked us for was the measure of LKM and the measure of MKN. So we need to go back and plug x in to solve for those values. So the measure of angle LKM is equal to 2x plus 10, which equals 2 times 23 plus 10, or 46 plus 10, which is 56 degrees. We also need to find the measure of angle MKN, which equals 4x minus 3, or 4 times 23 minus 3, which equals 92 minus 3, which equals 89 degrees. If you want to, you can go back and check this, and if you add 56 plus 89, you will indeed come up with 145 degrees. Our next example is very similar, except instead of giving us the total value of the two angles together, we know that our overarching angle is a right angle, so we have to use the definition of that to set up our equation. So 90 equals our quantity 2x plus 2 plus our quantity x plus 1. Now we can solve for x and then plug that in to solve for our two angle measures. So 90 equals 2x plus x is 3x, and 2 plus 1 equals 3. And then I subtract 3 from both sides and then divide both sides by 3 to come up with x equals 29. Now, I have to plug that in, and so the measure of angle EFH equals 2x plus 2, which equals 2 times 29 plus 2, so that is 60 degrees. Our other measure of angle HFG is equal to x, which is 29 plus 1, so that is just 30 degrees. When I add those together to check my work, 60 plus 30 does indeed equal 90 degrees. Congruent is the word we use in geometry to indicate things that are equal or the same. So congruent angles are two or more angles that have the same measure. So in diagrams, we use matching arcs to show that two angles are congruent. Here, you can see that both angle A and angle B have a single line inside them. Sometimes you'll also see it with a second one right next to it if you have more than one pair of congruent angles in a diagram. An angle bisector is a ray that divides an angle into two equal or congruent adjacent angles. So, in this case, if I have angle ACB, then ray CD divides that equally into two pieces. The other way you will see this is if it's not shown in a diagram, you may see a statement with this symbol here where it's an equal sign with a squiggle over it, and that means congruent. In our first example, ray YW bisects angle XYZ, and measure of angle XYW is 25 degrees. Because by definition, these two must be equal since ray YW is bisecting that, the measure of angle XYZ must equal twice that interior angle, so it is 2 times 25, or 50 degrees. In our next example, ray BD bisects our overall angle, angle ABC. It tells us that the measure of angle ABD is 4x minus 2, and that is equal to the measure of angle CBD, which is 3x plus 18. So first, in order to find the measure of angle ABD and the measure of angle ABC, we must find what x is. So we're going to do this problem. And so we're going to subtract 3x from both sides, and so on the left, we're left with just x. We're going to add 2 to both sides, so we are left with x equals 20. So now we're going to plug this in. So for measure angle ABD, that is 4x minus 2. So that is 4 times 20 minus 2. So the measure of angle ABD equals 80 minus 2, or 78 degrees. Next, we have to look at our overall angle, which is the measure of angle ABC. Since I know that 78 degrees is half of that angle, the total angle must equal 2 times 78, which equals 156 degrees.